out through the baleen plates. But because the edges are frayed, it creates a mat which acts like a sieve, and anything that is too big will get caught on that mat of frayed edges. But because the right whales move quite slowly, fish can swim out of the mouth. So you have to be big enough to be caught by the baleen, but also slow enough that you don't just swim out the mouth. So then we look at the North Atlantic right whale, which is the cousin of the southern right whale, and there are only about 350 of these animals left. They haven't recovered from whaling, and so a lot of studies have been done on this whale and also on what they're feeding on. And what they found is that the North Atlantic right whale feeds on this little animal. It's really tiny, but they actually find huge dense patches that give them enough energy to sustain the large whales. On our south coast, we have a cousin of that little animal, and it is well adapted to the environment that is more constant on the south coast. It doesn't have much food, but it has a constant supply of food. So this little creature is slow growing, but it can use the amount of food that is available. It doesn't need any more than that. Whereas on the west coast, food supply is very much variable, and it is displaced by plankton, calanoides. And this calanoides is very well adapted to the boom-bust system of the west coast. So just to put you in the picture, Hermanus is here by the yellow star, and then that is the west coast very productive system. If you live in the Western Cape, you may have noticed that the southeaster blows in summer, and it can blow quite hectically. So the water on the surface is blown offshore. You get deeper nutrient-rich waters coming in, but then the wind slackens. So because of the environment of St. Helena Bay, the water is retained within the bay. You have a lot of nutrients. You have a phytoplankton bloom. That means calanoides, which can use all this food, has also got a boom. St. Helena Bay actually has the highest productivity anywhere along the west coast because of this regime, and calanoides dominates it. Calanoides grows really fast, and then the stage just before it reaches adulthood, class 5, doesn't matter about names, it has a little lipid sac, which is energy rich. If the food levels drop, then the calanoides can actually sustain itself for 100 days on that lipid sac. If there's still a lot of food, it will then become an adult and the cycle will just continue. If there's no food, it can live for 100 days without having to feed. Energy for the prey also means energy for the predator, i.e. a large whale. If they're big enough plumes or swarms of plankton, then it would be enough energy to sustain the whale. And that is what I think the right whales are feeding on. We have taken plankton samples next to feeding right whales, and calanoides is always present, and generally it's present as the dominant species in the sample. But to make sure, we are looking at what comes out the other end. I have poo samples from both the west coast and the south coast, and we're looking at it genetically to see if calanoides is in all samples, and whether maybe that south coast species I showed you is in the south coast samples. Okay, thank you.